you ask the question, well, why is our universe so perfect for life? Why do stars make carbon and oxygen, the elements that you need for life? Why is everything so beautifully balanced so that living things can exist? Eternal inflation theories suggest that there might not be just our universe, the bit that we can see, but there might be many universes, perhaps an infinite number of them, and they may be being produced all the time for what happened before the Big Bang. It's interesting, this idea of the Big Bang created the universe. That's what Einstein's theory says. That's textbook cosmology, if you like. But the current textbook picture is there was a phase in the universe's life before the Big Bang, if you define the Big Bang as the hot, dense phase from which the universe appeared to sort of burst forth 13.8 billion years ago. And that phase is called inflation. So what we think happened is that before that, the universe was accelerating exponentially fast. It means it was doubling and doubling and doubling in size. And the numbers are ridiculous. We think that if you started with a universe that was smaller than a single atom, then it would be bigger by a long way than the whole observable universe, 350 billion galaxies in it, in less than a millionths of a second. So very rapid, exponentially fast expansion. And when that stopped, all the energy that was driving that expansion got dumped into space. It heated it up. It produced the particles of matter out of which we are made and all the things that we see out there in the sky. And that's what we see as the Big Bang. So that sounds fanciful, but that's standard cosmology at the moment. The big question then is, well, what started the inflation? What stopped the inflation? How long did the inflation go on for? And the answer to that is, we're not sure. We don't know.
In the beginning, there was an infinitely dense, tiny ball of matter, which started to expand and would eventually give rise to the atoms, molecules, stars, and galaxies we see today. But what was there before the Big Bang? What was the state of the universe before, well, everything? The universe underwent a breathtaking cosmic expansion, doubling in size at least 80 times in the fraction of a second. This rapid inflation, fueled by a mysterious form of energy that permeated empty space itself, left the universe desolate and cold. And only after that did the hot, dense conditions of the Big Bang emerge.
Some of those theories suggest that the inflation doesn't stop all at once. It stops in patches, and every time it stops, you get a universe. And so some of these theories, they're called eternal inflation theories, suggest that there might not be just our universe, the bit that we can see, but there might be many universes, perhaps an infinite number of them, and they may be being produced all the time. So what to make of that? Well, that's where current modern cosmology is.
If cosmic inflation correctly describes what happened before the Big Bang, it may push the ultimate answer to the question of where we came from beyond the reach of science. But that just pushes the question further, because we don't know anything about what came before inflation, and it's doubtful that we'll ever know.
There are theories now that suggest, as I mentioned, that there may be more than one universe, and potentially an infinite number. If that's true, then some of those theories say that what we call the constants of nature, so things like the strength of gravity, the speed of light, the masses of the particles, can vary from universe to universe. And then you ask the question, well, why is our universe so perfect for life? Why do stars make carbon and oxygen, the elements that you need for life? Why is everything so beautifully balanced so that living things can exist? The answer in these cases is because, well, every universe exists. Every possible combination of the laws of nature exists in different universes. So the reason we have to see a universe that allows us to exist, obviously. We could ask the question, well, how likely is that? Well, the answer, there are an infinite number of them, is it's inevitable, because there's every possible kind of universe. And I stress that this is very speculative stuff. But the first thing I said about inflation, the idea that there's this exponentially fast expansion before the Big Bang, if you want to use that language, that's not speculative. That's mainstream cosmology. But this idea that that may lead to multiple universes is more speculative. But it's still scientifically valid, and there are people who do research into that. And again, this is an active area of research.
Inflation tells us that the period of time before the Big Bang was extremely cold, and it was empty of everything but empty space. And that empty space carried energy that stretched the universe out to this enormous size. and into the initial state before the Big Bang. But there are also alternate theories to cosmological inflation, which tell us what caused the initial conditions that would eventually give rise to the Big Bang.
There's a theory there may be extra dimensions in the universe. So imagine that we're just living on a sheet of paper, let's say. Then there are theories where here's our universe floating around, and there can be another universe floating around. So there are more spatial dimensions, and we're just on a sheet floating around in this bigger multiverse. And then you can ask the question, well, what happens when they collide together? And one of the theories about what caused the Big Bang is that actually what it was two of these sheets, or brains they're called, that they collide together and separate. And when they collide together, they heat themselves up, and you get something that looks like a Big Bang on that sheet of space and time, if you like. So that's another different theory for what happened before the Big Bang.
Brains colliding into each other, giving rise to Big Bangs, multiverse theories. These statements might seem extremely speculative and out of touch with reality, but they do in fact have mathematical reasoning behind them. And moreover, theories describing the very early state of the universe do have experimental support.
The wonderful thing is that we're making measurements now. I should say the experimental basis for all this is something called the cosmic microwave background radiation, or the CMB. So we can look up into the sky and we can see the oldest light in the universe. It was released at 380,000 years after the Big Bang. It's when the universe cooled down sufficiently for atoms to form. And at that point, the universe became transparent, and that light has been travelling through the universe ever since. And we have a satellite up at the moment called Planck. It's a European satellite that's been taking detailed pictures of this light. And in that light, it's like a baby picture of the universe, like a scan, a baby scan of the universe in a sense. And so you can look to the universe as it was in its very earliest days and see different structures and different properties of that light. And they give you the clue as to what happened right back at the beginning of time, the beginning of the universe. And that's where these theories are getting their experimental support.
The twin pillars of modern physics are Einstein's general relativity and quantum theory. To understand how the Big Bang emerged and what came before it, it is essential to unite Einstein's theory with quantum theory. Only if we obtain such a theory will we be able to answer the ultimate questions in cosmology, like what is space, what is time, what is the universe, and where did it come from? The most distant objects in the universe are 47 billion light years away, making the size of the observable universe 94 billion light years across. If you are wondering how can the observable universe be larger than the time it takes light to travel over the age of the universe, the answer is because the universe has been expanding during this time, and this causes very distant objects to be further away from us than their light travel time. Most scientists think the entirety of the universe extends way beyond the observable universe, but is there anything beyond the entirety of the universe?
Is there anything beyond the universe? Probably not. We suspect quite strongly that our universe could well be infinite in extent, even our bit of the universe. If you just take our universe, we're sure it exists far beyond the bit we can see. So why would I say that? Well, if you think about it, the universe, our bit at least, has been around for 13.8 billion years. That means that light has only had 13.8 billion years to travel from the bit that we can see to our eye. So we can only see as far as light has had time to travel. But we think there's a lot beyond that because of measurements we've made of how the universe is curved and what the structure of the universe is. So it undoubtedly extends beyond the little bubble that we can see. How far it extends, it's another great question. We don't know, but it could be infinite in extent.
Taking into consideration the latest discoveries and measurements in physics, we have attempted to answer the questions. What was there before the Big Bang? How big is our observable universe, and what lies beyond the bit we can see? But are we forgetting something? An important question that naturally arises after we question the beginning of everything.
How will the universe end? Well, the current best guess, or best estimate, is that it will carry on expanding forever. And the reason I say that is because actually the universe is accelerating in its expansion, which is a great mystery, because before that discovery, we thought, well, gravity is always attractive. And so it should be, we've got all these galaxies in the universe, and the universe has been expanding since the Big Bang. And so it should at least be slowing down. And there was even a question as, is there enough matter in it to slow it down so much that it stops and recollapses again? But this new discovery that the universe is accelerating in its expansion suggests that it will continue to accelerate unless some new physics appears that we don't understand, and so it will just continue to expand forever.
Thanks for watching. Did you like this video? Then show your support by subscribing, ringing the bell and enabling notifications.